Hello, everyone, and welcome back to our second annual virtual summit. Today we have the first of, I believe, 6 different presentations that we have this weekend, and we're very happy to have with us Nicole Hayes from American Wild Horse Conservation. She's a conservation scientist, and she's here today to talk about their success in their fertility control programs. I do want to remind everybody that you're muted and your videos are off. And if you have questions, please put them in the chat and we will get to them after the presentation. I also want to remind everybody we haven't had any issues, but I know that fertility control is one of those breaking points for us as wild horse advocates. So I just ask that everybody continue to remain respectful and let Nicole explain their side of things and what they've done. And again, if you have questions, she's more than happy to answer, but just we aren't going to tolerate any rude or disrespectful behavior. So I just hope that we can continue to stay respectful. So thank you very much, Nicole, for being here and welcome.
Thank you. So as they said, I'm Nicole Hayes. I work as a conservation scientist for American Wild Horse Conservation. And today we're going to be talking about immunocontraception in a large population of free-roaming horses. So in my talk today, I'm going to give a fair bit of history as I think it really provides a lot of critical context for understanding wild horse management in the US. I'm going to quickly cover some equus evolutionary history in North America, their extinction, and then their reintroduction. I'm going to cover the more recent history, current legal protections, their current management, and then I'm going to get into our discussion of immunocontraception and our program and results. And finally, I'm going to touch on future implications from this work. And some of this may be very well known to people in this audience, but I really think it's important to go over the whole picture of wild horses. So the horse family Equidae began during the Eocene epoch around 50 million years ago. Equidae continued to evolve over the next tens of millions of years, and this evolution took place primarily in North America. The genus Equus, from which all modern horses are from, evolved around 4 million years ago. Equus was extremely successful and spread across the continents from America to Eurasia. Mitochondrial DNA has actually shown that horses in Asia and North America maintain gene flow across the Bering Land Bridge, which at the time connected North America and Asia. So these populations of horses that existed right around the Bering Land Bridge in Asia and North America actually kind of functioned as a single metapopulation. This gene flow is maintained through the late Pleistocene, at which time the extinctions of megafauna are believed to have begun. And the cause of this mass extinction is really greatly debated, and it's likely the combination of a lot of different multitude of factors. Through macrofossils, so the actual remains of the horses themselves, it was previously believed that both horses and actually woolly mammoths, the extinction took place some 11,000 to 15,000 years ago, and this emergence of the Bering Land Bridge prevented their return from Asia. However, DNA analyses have shown that both horses and the woolly mammoths persisted in multiple locations for thousands of years longer than previously thought. These analyses shown that horses were still around at least 6,000 years ago. And it's always interesting to note that confirmation of human hunting of horses in North America has been recorded in fossil evidence. So again, horses and humans did interact before their domestication and before their localized extinction in North America. The question of when, where, and why horses were domesticated is still really hotly debated. Regardless of exactly where and when horses were domesticated, they were then reintroduced to North America during the Spanish colonization of modern-day Mexico around the 15th century. And contrary to previously held beliefs that Europeans further brought horses across what is now the United States, recent evidence has shown that horses reached many areas of the US prior to colonization, and that horses were deeply integrated into indigenous societies well before the arrival of 18th century explorers. Horses were really vital to the development of the American West. They were used for transport, mining, farming, ranching. By the 19th century, bands of wild horses roamed most of the American West from California to the Mississippi River, especially on the Great Plains and Central Valley. Although these horses were from domesticated stock, they were returned to the location they evolved in for millions of years, with the flora and fauna, as well as predators they evolved alongside with. These free-roaming bands also provided horses for anyone who could catch them. Roundups of wild horses provided income for Mustangers who sold them to meat for meat or to the U.S. Army for cavalry mounts. However, by the turn of the century, reliance on horses really shifted to mechanized transport. Around the same time, unsettled rangelands were organized under the government, and they began limiting the number of ranchers and the number of livestock allowed on the range in an effort to reduce overuse. This drove up that competition between ranchers and wild horses as grazing on these public rangelands was no longer free. Agricultural depressions followed both world wars, and wild horses were further rounded up for cheap meat for human and then pet consumption. By the 1950s, it seemed to most Americans that wild horses and burros might disappear completely from public lands. Through grassroots movement and mounting public interest and concern, the federal government unanimously passed the Wild Free Roaming Horse and Burro Act, which was signed into law in 1971. This gave wild equids protection on public lands where found at the time of the passage of the act. The act specifically protects wild horses against capture, branding, harassment, or death, and stipulates that these horses are to be considered an integral part of the natural system. So now that there are laws about managing wild horses, let's talk about what management really entails. In the 2015 population census from the BLM, which of course, as you guys know, is the branch that manages a lot of wild horse populations in the US, they estimated there's approximately 54,000 wild horses on public lands. Of the 245 million acres of public land that the BLM manages, they only allow about 29 million for wild horses. But they allow 155 million acres for private livestock grazing. As you all well know, the BLM has primarily managed these populations through helicopter gathers, where if an area is deemed to have too many horses, these animals are then taken off the range. Any excess gathered animal that's not adopted is then placed into long-term holding government facilities for the remainder of its life. Currently, there are more than 60,000 horses in these long-term government holding facilities, which, if the BLM population estimates are correct, there are currently more horses in long-term holding than on public rangelands. So this current method of taking horses off the range and stockpiling them is clearly not a reasonable or fiscally responsible solution. However, the use of immunocontraception offers another viable and potentially significantly less expensive alternative. So let's briefly touch on the history of wildlife contraception. So efforts at controlling wildlife populations via contraception began around the 1950s. A lot of these original attempts involved natural and synthetic steroids and other compounds. So although these studies were successful at actually preventing conceptions, the trials were pretty much considered a failure because, especially with steroids, you have lots of toxicity, passage through the food chain, high cost of application, difficulty of delivery, as well as health risks, especially for pregnant animals. So steroids can be very useful in captive wildlife contraception, but really abandoned for use pretty quickly in terms of free-ranging wildlife. But with the introduction of immunocontraception, there's a lot of significant progress that was made in wildlife contraception. The earliest recorded wildlife immunocontraception pilot program was a gonadotrophin-releasing hormone vaccine that was tested in the horses of the Cumberland Island National Seashore in 1986. The results of this pilot program were really not promising. And so after they did a study on porcine zona pellucida, or PZP vaccine, that was tested in captive and wild horses, and they did have a lot better results with that. So the original PZP studies really provided evidence that immunocontraception could be successful in horses. So what is PZP? We talk a lot about it, but we don't always talk about what it actually is. So PZP is an immunocontraceptive, which is porcine zona pellucida, and it's naturally occurring glycoprotein. And so the origin of the PZP contraceptive can actually be traced back to about the 1970s. And two main researchers published a lot of different studies on different small mammals showing that PZP proteins could be useful as a contraceptive vaccine. So what did they see? How does this work? So eggs are surrounded by a zona pellucida membrane, and it has protein receptors. And these receptors act as keyholes that the sperm can bind to and then penetrate that outer layer. So the sperm also have surface proteins that allow that binding and then penetration and allows that fertilization of the egg. So to prevent this, the PZP is injected into the animal, which creates an immune response, creating antibodies. These antibodies respond to the PZP and then search for similar molecules to bind. And so they bind to the protein receptors that surround the egg of the treated female, and they block the sperm attachment, and thus they block the sperm penetration. And so it's just a physical binding of the exterior of the egg, blocking the fertilization. So it doesn't actually interfere with any other aspect of the reproductive cycle. And so in the 1980s is when this was first used in horses. And there have been continued studies since then in free-ranging and zoo populations of numerous species, and has shown the ability to manage many different species and populations, including in urban deer, in elk, in bison, in African elephants, and of course in wild horses. So let's talk efficacy and side effects. In 2013, the National Academy of Science published a review of fertility control for wild horses, and they found that PZP had a mean efficacy of 91.5%. They calculated this using studies that had both a primer and booster dose in the first year of treatment, which is shown to have the greatest efficacy. A major advantage of using zona proteins as immunogens is the lack of cross-reactivity with other tissues. So it's not interacting with other parts of the body and those hormone pathways. Because of this, PZP has no effect on current pregnancy or lactation and is found to have no effect on full survival or full fertility. Additionally, it's been shown there's no permanent or significant changes in the ovarian endocrine parameters or estrus cyclicity, even after long-term treatments. Treatments with PZP have shown increased longevity and body condition scores in the treated population. A study has found decreased female band fidelity. However, those same authors reported that male fecal cortisol concentrations, so those stress concentrations, did not vary with increased female turnover. So it's not actually thought to increase stress in these herds. While some studies have noted a longer breeding season, resulting in foals being born out of season, this was not correlated with a decreased survival in those foals. Studies have found there's no observable difference in activity budgets, so how these horses spend their times between treated and untreated females. And aside from increased reproductive behavior due to lack of pregnancy, and therefore continued estrus behavior. Excuse me, just getting over a cold. While there have been reports of injection site reactions, particularly with those remote delivery methods, these reactions seldom exceed 1% of treatments. So PZP use for population level fertility control in wild horses was first utilized on the Assateague Island National Seashore, which is a barrier island off the coast of Maryland. Beginning in 1988, the National Park Service regulations prohibited the capture or handling of any of the horses during the study. So the inoculation was delivered remotely with an air rifle. At the beginning of the study, there were just over 140 horses within the boundary of the park. And the Park Service has now been utilizing PZP on this population completely with remote delivery, successfully controlling growth rates for the last 35 years. In the years since, PZP has been used in numerous other studies and long-term fertility control programs, but these have really tended to be in small populations of wild horses and in limited habitat areas. So despite the accepted contraceptive efficacy of PZP vaccines via remote darting in wild horses, there's a lack of reports investigating the efficacy and evaluating the feasibility of immunocontraception programs in larger populations of wild horses. It was previously stated and believed that for these type of really expansive Western environments, a single dose formulation was essential to be able to treat wild horses. So how does this look as a management tool? Because that's really what it is. It's a tool that can be utilized. And so it has an efficacy of over 90%, meaning that it prevents reproduction in over 90% of the female horses treated. It has the ability for remote delivery with CO2 powered dart guns. It's reversible, so we're not permanently sterilizing. It's safe for pregnant and nursing animals. It has no effect on a current pregnancy, so mares can be treated during any point of a current pregnancy. Data has shown an absence of short and long-term health side effects. Minimum effects have been reported on social organization and behavior. And in fact, it's been shown to improve the health of treated female horses. And why is this? This is really due to horses having an 11-month gestation and then a period of around a month between successive pregnancies. So this is a really long, energetically taxing endeavor for them. And so by removing that and not having that every year, that mare is able to put a lot of her resources into her own body. And that's really where it's improving health. And finally, there's no ability of this vaccine to pass through the food chain because it's non-hormonal, non-steroidal. And so when we're evaluating different solutions for population management, we have a few criteria we like to fulfill. So first, is it humane? Is it safe for the animal? Is it effective? We don't want to be doing something that's not actually getting the results we'd like. Is it reversible? Is it minimally disruptive to the animal and their interactions? Is it scalable? And is it cost effective? So as we've seen in the literature so far, PZP is humane. It has over 90% efficacy. It's reversible. It's minimally disruptive on the animal and their family units. So now I have the question is it scalable? Is it cost effective? So this brings us to our Virginia Range Fertility Control Program, which is the results we're going to be discussing today. So the Virginia Range Fertility Control Program is a cooperative agreement between American Wild Horse Conservation and the Nevada Department of Agriculture, or NDA, to treat the free-roaming horses residing in the Virginia Range, located just outside of Reno. The program's aim is to treat breeding age mares using native PZP via darting. The program first began in March of 2015. However, in October of 2017, the state of Nevada did halt the program. But on April 9th of 2019, permission was reinstated and our current program began. This program requires an agreement with the state of Nevada because the horses that reside in the Virginia Range are under the jurisdiction of the state, and thus they're not managed by the federal government or the Free Roaming Horse and Burro Act that does not apply to them. So they do not have that level of protection. So here we have a map of the Virginia Range. So it's situated in western Nevada. It's around 300,000 acres, just to the east of the city of Reno that you can see up top. The habitat's semi-arid, high elevation desert, really consisting of sagebrush, rabbit brush, a variety of grasses. The free roaming horse population here resides almost exclusively on private land, with a very small amount of public land interspersed, and as I said, is managed through the NDA. The population's about 3,500, and this herd's really an integral part of Northern Nevada's history and culture. This is the herd that inspired Wild Horse Annie to begin her movement that resulted in the Wild Free Roaming Horse and Burro Act. For these horses, management's crucial because they're losing habitat daily. Anyone who's seen the Reno area, it's developing quickly industrially and the city expansion. And because this is all private land, these horses are losing that access. Although the Virginia Range is bound in the south by the Carson River, darting permission for the program is only valid to Highway 50, which you can see. Let's see if you can see my mouse. Down here is Highway 50 versus this is actually the Carson River. And Highway 50 is unfenced for large portions, in addition to having wildlife underpasses. And so horses can cross back and forth between these areas. And because of this, the horses residing in this dot-filled area remain largely untreated due to these restrictions. Additionally, that far eastern edge of the map, you can see in the line fill, we didn't begin documenting or darting activities in this area on this population until around 2022, when the program had been expanded to include these areas. Individual identification of the horses is really the key to success for this program. The database was started in 2015 when that first program began. Horses are individually identified using herd treatment area. So we break that huge area of the Virginia Range up into smaller areas. And then they are also obviously have band affiliation, gender, the colors and markings. As of December 2025, there were individual records for over 7,000 horses, where 3,400 were living, 180 removed, and about 3,500 deceased. And that's really important to understand here that this deceased horse count includes a lot of historical records. So people have been following this herd for many years longer than this program has existed. And those horses were entered into the database for genealogical reasons. So to keep those family histories alive, as well as also including full deaths each year. Within the database, individual horse records also contain identifying color photographs, coat color, gender, distinctive markings, date of birth when known, location, band changes, births, dam and sire when known, and any injuries or other conditions. Any new foals that are found on the range are assigned to the dam based on either affiliative behaviors or when the birth was witnessed. All foals are assigned a date of birth based on the appearance of the individual foal when it's first observed, and the individual mare's final observation before her partition. And this is a continuously updated database based on field observations reported by the volunteers. And that's really a critical component of this program, is to have an extremely detailed, continuously updated database of all the horses on the range. And so as you'll see here, AWHC has actually developed our own database for managing these populations that allows us to track individual horses' life histories as well as their treatments. So here I have an example from the database. So as you can see, I'm under the horses tab. On the top, you have the identification name and ID number. Why do we name them? Because when you're discussing a horse or discussing treatment, Paisley is much easier to place than horse 5412. Underneath the name and ID, you have photographs, and they're usually in the same order for each animal. So you have a face shot followed by either side, and then you'll have the following photos that help you identify. So shots from behind, as well as close-ups of each foot and foot markings. When you hover over the photo, like you can see here, that black bar pops up and it tells you the date that photo was uploaded, as well as the ability to make it full screen. You'll see the markings are in their own section. All of this information about the horse is all searchable in the database. If there's any unique markings or scars, you'll see that. You'll also have location and family band, as well as details including her current status, gender, when the file was created, and when it was uploaded. So this is just scrolled down from the previous screen. And so there's a few different tabs where we can track each darting a mare has received, which is what you're seeing here. I have removed the names that aren't my own, but as you'll see, there's meta information for each darting. And if you click on the three dots on the right, there's even more information on each darting. Next to the darting tab, you'll see a little stethoscope, which is where we track injuries or observations for that horse. The next little tab is a calendar. That's for events. So it's where you can see the history of the horse. So if they've moved between areas, moved between bands, that's all tracked there. The next tab is for photos. So it's those same photos we saw higher on the screen, but it's just an area to upload those photos or reorder them. Next to that little image is a little family tree. And so that's where you can see each horse's family connections. So dam or sire if known, any offspring. And then finally, that last tab is our file log, where you can see what's been edited, what's been updated in that horse's file, and by who. And so this system allows us to search any field and run reports on the data within our database. So having a thorough database is critical, but really our volunteers are the core of our success. Can't thank them enough. Horses are monitored and darted by a team of volunteers of 18 darters and 20 documenters. Darters are, of course, responsible for darting, while documenters help identify and track horses on the range and keep their records updated in that database. Each darter has underwent training and certification by the Science in Conservation Center in Montana. An important aspect of our program in particular is that documenting and darting activities occur year-round and encompass all seasons. So a lot of previous PZP programs have utilized seasonal darting, so they'll go out and dart right before breeding season. But in our program, due to its sheer size, we dart opportunistically all year round. All observations, records, and treatments are updated in the database on the same day that they are taken to make sure that the most up-to-date information is available before someone were to head out that next day. Within each mare's record, the fertility control applications are recorded and include type of action. So if she receives a primer or booster, date, side of the horse that started, distance of the darting shot, the amount of CO2 used, the number and type of dart used, the type of delivery method, observations of any treatment reactions, and the darter's identity. So each day prior to darting, our field teams have access to a report that lists individual mares that are requiring vaccination within a selected area. The team then goes out and explores that area and opportunistically darts any mare that's identified as requiring treatment and records that in the database. So little on the vaccine methodology. All mares older than 8 months of age are slated for treatment. So when a mare gets her first treatment, she requires a primer dose. Once a mare is primed, she requires a second booster treatment that is administered at least 2 weeks after her first primer dose. Once a mare has been primed and boosted, she's boosted again every 8 to 12 months. A mare is re-administered a primer dose if she never received that first booster dose within 12 months, or if she hasn't been boosted within 14 months of her last booster. Or finally, if she foaled and we didn't have any recorded gaps in treatment, then she's reprimed and restarted with her treatment. Once a mare has been positively identified and confirmed to be requiring a vaccination, the darter thaws a vial of PZP and emulsifies that with an appropriate adjuvant. The emulsification is then loaded into darts for delivery. We use a 1 milliliter, 1.5-inch barbless needle, and that's discharged from either a DanaJect or new dart air rifle. Once a shot's taken, the dart then drops from the mare. The dart's gathered, and we check every dart that the plunger has engaged, allowing us to confirm that the dose has been delivered. If a dart does not immediately drop, the mare is followed until the dart detaches. If the dote's not confirmed to be delivered or the dart cannot be located, the attempt is labeled a misfire, and so the mare is still slated for retreatment. Okay, so now on to the results of this program. First, I'm going to present on the data we published in 2024. That's the paper you can see here. There's also a QR code if you want to download this paper for yourself. It is open access, so it's not behind a paywall. I also we'll have the QR code on the last slide in case you miss it here. So I'm going to really briefly discuss the analysis, but you can always reference the paper if you want more details on how we performed the analysis. As we discussed earlier, there's areas of the range we don't have permission to dart, and the horses can cross that boundary at many different points. So horses that spent greater than or equal to 12 continuous months outside our geographic limits that are set by the NDA for darting were removed from the analysis. This 12-month period was used for exclusion because this interval coincides with the end of the treatment window for that first booster, and thus the mare's treatment is considered to be expired. It's important to note that this exclusion criteria does not remove horses that continually cross back and forth across the boundary, even though this does result in mistreatments. Additionally, horses that are residing in that far eastern edge of the range that I showed earlier in that line fill were excluded from this analysis because they'd only received 1 year of treatment during the study's observation period, and so efficacy data was not available yet. After this removal, individual records for just over 2,800 female horses, including 1,700 living, 22 removed, and 1,000 deceased, were included in this analysis. So mares were separated between mature, so over 1 year of age, and immature, less than or equal to 1 year of age, based on their reproductive potential once they reach over a year. Total mares, total vaccinations, total mares vaccinated is summed across each group of mares. Total observations of any darting associated lesions were summarized and characterized as either granulomas, so that's just raised swelling, or abscesses, which is open and draining. Full births were summed by month and year, and full births were also used as a proxy for the previous year's conception based on a gestation period of 354 days. The assumption is that the actual conception rates were likely higher due to undetected pregnancy or attrition at any stage between fertilization and parturition. So here we have the first section of our results. And so this is our PZP treatments. During the first year, beginning in April of 2019, a total of 780 out of 1,528 mares were treated, or roughly about 50% of mares. And this consisted of just about 1,200 treatments. Over the second year in 2020, 1,070 mares were treated, totaling about 60% of mares. By the end of the study in 2022, 1,257 mares were treated in this year alone, and a total of 1,425 mares were treated with at least 2 doses, equaling 73% of the total mare population. Mean vaccinations per mare also steadily increased, so how many doses a mare had received. By month 12, mature mares averaged just over 1 vaccination. By month 48, so after 4 years, mature mares averaged just under 4 vaccinations. Observations of externally visible side effects of DART delivery included those draining abscesses or granulomas. As you can see, these lesions are extremely infrequent, usually around 1% of all administrations. Prevalence was highest in 2022, with around 0.5% of granulomas and just over 1% of abscesses occurring during the total almost 2,000 administrations. In 2019, a total of 392 full births were recorded, which increased to 488 in 2020, which was the first full year of the program. We will be discussing this apparent increase later in the talk. By 2021, however, full births were reduced by 45% from the year before of only 267 births. In 2022, full births were further reduced by 58%, totaling only 205 births. The sex ratio between these full crops is relatively even, with the exception of 2021, where it was slightly skewed towards females. I wanted to take a moment to discuss foal mortality. So foal mortality here includes all deceased foals less than 1 year old with a death recorded in that year, even if the birth was in the preceding year. So as you can see, because of this analysis, the lowest foal mortality was in 2019, simply because likely many of the 2019 foals that did pass away were included in the 2020 mortality count. Although the number of foal deaths decreased from 2020 to 2021, the percent survival also decreased. So we had a 63% mortality occurring in 2022. However, this apparent increase in foal mortality is likely associated with just increased range coverage and increased ability of observation before the foals have reached 1 year of age. Now, this mortality is not a side effect of treatment. But with less and less foals in each year's crop, there's a higher predator to foal ratio, resulting in higher mortality percentages. It's also interesting to note that in 2021, where the foal ratio was slightly skewed towards females, there was a concurrent increase in female foal mortality, and that actually resulted in a relatively even foal crop. So here we have the seasonality of foal births and conceptions. So with PZP or any type of fertility treatment, there's always a discussion of seasonality of foal births. Now, as we've already covered, most fertility control programs before this one were on a much smaller scale. So this program includes thousands of treated female horses, giving a better idea of how treatment affects birth seasonality of an entire population. Here we can see, again, that increase in births from 2019, that's in red, to 2020, that's in green, however, followed by a year-on-year decline. Most notably, what I really want you to take away from these figures is there's no apparent widening or shift in peak foaling season that we have observed. Foals born in 2019, so that red, were conceived in the year prior, so in 2018, and that had no treatment effects as the PZP program had not yet begun. As you can see, there are always some foals born out of season. It's naturally occurring in populations that even aren't treated. In fact, the highest number of foals born outside of peak foaling range was in 2019. When foal births were used as a proxy for conceptions, in 2019, at least 488 mares conceived, comprising of 32% of the mature mare population. By 2020, that was more than halved, 15%. And by 2022, only 10% of mature mares are recorded as conceiving in that year. So here we have the trend of total mares in the population along with their pregnancy status. In terms of overall population, we're concentrating on mares since they are the ones that provide the means to grow the population. So we're looking at the top line in red, which is mature mares in the population. So even with improved observations over the entire study period, there was only an increase in total mares until month 29, a little over 2 years since the program's inception. And even with this apparent increase in mature mares, there's a decrease in the number of pregnant mares across the study period starting in month 5 of the program, which is that blue line you can see at the bottom. The number of pregnant mares peaked in month 5 and then sharply declined by 67% by month 43. In addition, the data has shown a shallow but decreasing trend of total females in the population beginning in month 29 of the study. Okay, so now we're going to discuss all those results we just went over. What does that all mean? So by the end of the study's observation period, around 3/4 of mature mares had been vaccinated at least once, with individual mares averaging around 4 treatments. And again, we're talking over 1,000 mares, so keep that in mind when we're discussing scalability. During the final year, 2/3 of mature mares received treatment, which results in a foaling reduction of almost 60%. Through month 29, the mature mare population increased, but that increase was associated not only with the natural maturation of mares that were already in the population, but the steady increase in access to mares and the expansion of our programs, the expansion of our range coverage. At the beginning of a program really has to first identify and document the population. So though it will appear that a population is increasing, it's actually just the result of increased documentation and shouldn't be a deterrent to starting a program. This is just something you have to come to expect. Our data has demonstrated that increased population coverage is clearly associated with both declining reproductive and foaling rates. Treatment data showed a 35% increase in yearly vaccination administrations. So each year of the study, we were getting better and better at treating more mares. Several reports have previously highlighted the critical importance of population coverage as a predictor of success. So Grams and others in 2022 referenced that about 60 to 90% of mares, depending on the situation, would need to be treated to achieve a stable population in the absence of removals. The study's current vaccination coverage falls within this range, and the yearly rate of increased administrations suggests that this is a very feasible goal. Furthermore, our current study's observations suggest that sustained treatment delivery, which is stated as one of those critical criteria for success, is possible even in these large, extensively distributed populations inhabiting challenging terrain. And this has really contradicted that caveat that this method's success, so PZP administration, is only achievable in small, discrete, and easily accessed populations. The Virginia range itself was previously reported as impractical and cost prohibitive for a multi-year PZP vaccination program due to the large resident population and extensive area. This program, however, achieved vaccination coverage within 4 years in a range of almost 300,000 acres. Importantly, this includes mares that spent up to a year outside the approved darting boundary, again, resulting in those mistreatments. Furthermore, despite assertions that a single dose formulation is an essential prerequisite in free-roaming horses, this study's results show efficacy and feasibility despite its reliance on a multi-dose formulation. There was a perceived increase in foaling rates in 2020 compared to 2019 that I said we'd come back to. So again, at this program's inception, especially at these large geographic and population scales, it really should be anticipated that a lot of time is required to develop and really optimize your observational efficiency. So it's almost certain that our recorded foaling in 2019 was an underestimation of the full foaling rate. Since we were just getting the program up and running, it didn't start until April, and we were working on having coverage for the entire range. Also, an equine gestation period of around that 11 months really implies that a lot of our mares that we treated in 2019 were likely already pregnant at that time of initial vaccination. So that contraceptive result really couldn't be observed until that second foaling season, so in 2021. So an advantage of PZP administration, however, is that it doesn't have any negative effects on pregnancy in treated mares and can be safely used in any point of gestation. For the Assateague Island population that had been using PZP for over 35 years, zero population growth has been achieved after 2 years of treatment. However, population decrease was only apparent after 11 years. This slow rate was due to the advantages in animal welfare caused by PZP treatment. So increased longevity, reduced mortality rates, improved body conditions of the treated mares. However, a population decrease will arguably expected significantly sooner when considering the Virginia range population due to its high mortality associated with documented predation. This was highlighted by that high full mortality rate due to that higher predator to full ratio as birth rates have fallen. So really want to touch on this predation. It's been perpetuated time and time again that wild horses in the American West do not have any natural predators. Predators in the West have been removed for human and livestock interests for hundreds of years. So while some areas of the US may not have population levels necessary for that top-down level control, it's not because horses don't have predators. It's because, at least partially, those predators have been removed. There have been numerous studies showing how especially cougars predate both wild horses and burros. The Virginia range is especially unique in that it's actually had collaring studies in this area of cougars, which has proven that they actually specialize on horse. This is in addition to the numerous case studies we've personally documented in our own data set of predation on horses with both survivals and mortalities. There's actually recent data that's just come out this year out of Alberta where they analyzed predator scat and actually showed that wolf, coyotes, cougars, and grizzly bears all had samples showing consumption of horses. So continuing our discussion, by December of 2022, only 1/10 of mares in the population had conceived. Importantly, there's no shift in that conception seasonality. There's no observed extension of the foaling season, as has been suggested by previous studies. The proportion of total mare population that was pregnant almost halved after only 2 years of treatment, and the number of pregnant mares declined by 67% by the end of the study. Okay, so that was all the results from our published paper, which again, you could download and delve more into. But now we're going to touch on more recent results of our program, because as I mentioned, this program is still ongoing and now entering its 8th year. And I just pulled this data this week. So this is on that same area we just discussed in the, was covered in the paper. So here we have our foaling graph showing births each month per year. I started in 2020 since that was the first full year of the program. But again, even the data in 2020 is likely still an underrepresentation of the total foal counts. We are seeing consistent year-on-year reduction in birth rates on the Virginia range now that the fertility control program has momentum. So let's look at 2020, which is in that light blue, and then 2025, which is in that dark blue. Foal births in 2025 compared to 2020 declined by 76% in these darted areas. And even with such low foal births, where you're able to reduce that population, you're still seeing that seasonal peak in spring and summer. So even all these years in, we're still not seeing any shifting or widening of that foaling season. So what does this all mean? What have I been talking about for the past 40 minutes? I threw a lot of numbers at you, so let's kind of sum this up. This study has shown that sustained multi-dose administration of PZP is able to achieve reduced growth rates on even a large and extensively distributed population. It's really critical to note that this occurred despite additional challenges in applying immunocontraception in extensive areas, as well as having these connective areas that were not allowed to treat with PZP. Population coverage reached 72.5% within 4 years, which resulted in almost a 60% reduction in foaling. This was possible despite the additional complication of those mares missing vaccination due to their movement outside the darting area, and the first year of the study not receiving approval until April, which in our area is peak foaling season. And as you saw with the 2025 update, we've now reduced foaling by 76%. And again, I really want to reiterate here that the goal of our particular program is population reduction. These horses are losing land every day due to development, and they don't have any federal protections. Some areas or other programs may not have the goal of population reduction, only population stabilization, and thus they can choose to have lower population coverage to achieve these goals. So it really depends on your individual goals for a population. And of course, most importantly, this method of immunocontraception was associated with providing effective, humane, practical alternative to that previous reliance on lethal, logistically demanding, or inhumane control methods. This really could not be accomplished without that robust data set of individual records of each horse. So now we're going to go all the way back to that checklist. So here we've shown that success on a large population of thousands of horses that covers almost 300,000 acres. So we've shown that fertility control can work at scale. So now all we have left is cost. Each dose of PZP is $35, and the estimated lifetime cost of fertility control treatment is about $3,700 per mare when calculated with a darter salary. Now, this will vary a bit depending on your specific situation, but let's take this as a ballpark. The BLM themselves have estimated the lifetime cost of a horse and holding is $48,000. And that's every horse, male and female, versus fertility control you only need to treat the female horses, so around half the population. The BLM hasn't released a lot of numbers for 2025, so we're going to look at some of their 2024 numbers. In 2024 alone, the BLM spent $107 million on off-range holding and only treated a little over 1,000 mares with fertility control. There are already over 60,000 horses in long-term holding, and every year they conduct roundups, that number just grows. And we've already touched, there are already more horses in BLM long-term holding than on BLM managed public lands. So this current method of taking horses off the range and stockpiling them is clearly not a reasonable or fiscally responsible solution. So as you can see, PZP offers that more fiscally responsible option where you need management and officially checks our final checkbox. So in conclusion, there's just a few points I really want to leave you with. We've shown that PZP is proven to be feasible in large populations where they're extensively distributed in challenging terrain. We've shown that PZP is a viable solution to help with on-range management. Most importantly, this program really creates a replicable model for a volunteer-based remote field darting immunocontraception program. And of course, this work adds to that ever-growing body of evidence that immunocontraception provides an effective, humane, and practical alternative to the current logistically demanding control methods. And with that, I want to thank you guys for your attention and go ahead and go through any questions you may have. As I promised, I would put that QR code to the paper up here for anyone who is interested.
Thank you very much, Nicole. I appreciate it. One thing I wanted to ask, it did say throughout the paper that this was native PZP. Is that what they're using? Can you talk about the different types of PZP?
Sure. So we use what native PZP means is that it is extracted from the pig ovaries. They're currently working on developing a synthetic version where they create it in a lab. That's not actually publicly available yet. I think they're having some issues with this having the same level of efficacy. And then on top of that, there are a few different formulations of PZP. And so those are often given with different adjuvants or different delivery methods.
All right, so questions that we have are, what efforts are being taken on the Virginia range to secure range and habitat for both horses and wildlife as rampant growth continues?
Yeah, that's a really tough question because as you know, land ownership comes with a lot of responsibilities. And so we're trying to work with current landowners because as we said, this is primarily private. So there is no guarantee that these horses will have rangeland in 20, 30, 50 years is the really harsh reality of where we're working. And so we're really trying to work with current landowners to maybe put aside land for open spaces, for wildlife, for water access. And so we're trying to work with the city, with the county, with the state, as well as with big business who own a lot of the land out there to try to hopefully secure that for the future. But I'm not going to lie to you, it's tough. It's a tough situation.
So when there is a PZP side effect, are there any interventions? So like are antibiotics given or anything like that?
So we don't directly interact with the horses in that way. There is a large animal rescue team, as well as a range management team. So out on the Virginia range, we're really lucky to have many different groups that help conserve these horses. And so we monitor these horses for any of those side effects. And again, you're really seeing less than 1% of all your administrations. And they almost always just resolve on their own. But if any type of intervention is necessary, we report that to range management. And along with the veterinarian, they will make a decision. So it's not really something we do, but we do have teams and other organizations that we work with that do look after that for the horses.
With population reduction, how are you ensuring that genetic diversity in the herd is maintained?
Yeah, so we don't have 100% treatment in any, well, what we have done, back up a little bit, is we've taken that big range, so you have a huge area, and we break it apart into those smaller herd treatment areas. And this lets us manage based on smaller areas, so we know that there's still genetic viability. But again, this range is completely interconnected. So you're looking at, 3,500 horses at this scale. Genetic variability is not a concern we have. As the population comes down, it's absolutely something we'll have to take into account. But we're still able to, through the database, manage and see if mares have contributed to the gene pool, who's contributing. We're able to manage that because of how in-depth our data collection is, and could take any actions we deem necessary. But again, I reiterate, these horses may not have a home in 50 years. So unfortunately, the reality of this situation is we do have to keep treating. But it is something we do keep in mind, and we are monitoring through our database.
I also know I've talked to the chief of resource management at Assateague Island, and they use PZP in their program. And he said if there ever is a genetic line that seems to be weakening, or like, there's less mares that hold that genetic, those mares are like off limits then and are not given any PZP until they can rejuvenate that genetic line. So there are responsible ways to do that, I believe.
Yeah, and that's the thing with these programs that have individually identified animals is we can make those decisions. We have all that information. So if we did need to make a decision to preserve a line, or say a certain herd area isn't contributing to the gene pool, that's something we can make a decision about, so that we do have the ability and we are monitoring those situations. But when you're talking a population of 3,500, that's not a risk we are currently a situation we're currently in.
So is there a population goal or a number of horses that you're targeting to get to on the Virginia range?
Unfortunately, no, because we don't know what their future is. If we had a guarantee of 100,000 acres, and so we know that we would always have this 100,000 acres for these horses to exist on, we could make those kind of goals. But we don't know what tomorrow brings with the amount of development, especially, data centers going in, housing projects going in. We have no idea how much range we will be able to conserve these horses. So we're not able to make those kind of plans, unfortunately.
Someone else is asking who funded the study. Was this all like from donations to American Wild Horse Conservation, or were they grants?
Yes. Yeah. So I believe we have some private grants. They were all non-governmental grants through different nonprofits that philanthropic grants that we were able to get, but almost primarily driven by private donations from small people just willing to help us along. So I can't thank them enough, but no government grants or government money has gone to this particular project.
And this program is still ongoing, right? There's no
Yep.
end
There's
date.
no end date. We currently have a signed agreement through September of this year. We do have to re-sign with the state every year so far. So, any support is always appreciated, even if it's just an email to the state saying that you appreciate this program, because this is a collaboration with the state and we do need their permission to run this program.
Can you talk a little bit about the training, what the training entails for darters?
Yeah, great question. So this is all through the Science and Conservation Center. So the SCC, that's based out of Billings, Montana. And our darters will either go to Billings or will actually fly the experts out from the SCC. And there's a 3-day intensive, all day long training where you learn the history of PZP, you learn the science behind it, you learn how to appropriately mix the darts, how to appropriately decide what mare needs to be treated, what dose she needs to be treated with, as well as learning about the air rifles, how to properly load them. You do a ton of target practice. And so by the end of those 3 days, you're then paired with one of our experienced volunteers and you actually shadow them. And you have a secondary checklist that you must complete before you can dart by yourself. And so then you're shadowing one of our more experienced volunteers, learning some of what works, what doesn't work, as well as just different things on the range you need to keep aware of.
Um, Ginger says, thank you for this important scientific study that will discredit the BLM's position that PZP cannot be used on very large herds covering large areas. Will you be presenting this at any scientific conferences or wildlife fertility control conferences?
Yes, great question. Thank you. I appreciate that. We are trying to get out and present this kind of everywhere who will take us. So if you do have leads on anything else, please send them my way. I would love to see them. But yes, I am actually have a talk at the International Wildlife Fertility Control Conference that's being held in Barcelona this year. And so that conference is specifically on fertility control of different populations. So really showing experts in the field that this is possible for wild horses and maybe hopefully getting a lot of investment even internationally, that this is a successful way to help with on-range management. As well as looking into several other conferences that I have abstracts submitted for and are waiting to hear on their acceptance. But if you do have any other suggestions, please email them over to me. I'd love to hear them.
Will a controlled PCP program enable currently corralled wild horses to be released?
Oh man, that's a tough question that I wish I had the power to answer, but I don't think I do. All the horses that are currently off range, their future is so unknown. I don't know that what will come of it. I'm hoping that this at least shows that on-range management is completely feasible. And so by keeping horses on the range, we stop any more of that movement into those off-range corrals. So I wish I could better answer that question for you.
So another question. Thank you for this, Nicole. We need to address adjuvants for sure. They're traditionally very toxic and can cause major health concerns in humans, so they're rightfully at the heart of the debate, the vaccine debate. Are there plans for tracking this and the health effects of predators consuming PZP?
Yeah, so we personally don't work with any of the predation groups, but there are a lot of groups that are monitoring the predators out here. And so the adjuvants that the question's about, so we use Freud's complete adjuvant or incomplete adjuvant. And they are currently working on different adjuvants to add so that we don't have to utilize those same adjuvants, but they do break down in the body extremely quickly because again, um, it's a 1 cc dose that's delivered to this animal, and then that immune system really takes care of it. But we are always looking for better adjuvants and are completely open to anything once they hit the market.
Is there anyone specific in the state that we can contact to say this program is appreciated?
The governor is a great place to start, or the Nevada Department of Agriculture. I likely start with our governor because he is kind of the head honcho of the state. Just let him know that you appreciate that we provide this program at no cost to the state and you'd like to see it continue. I think that would be wonderful if you were to do so.
Is there any research being done where darting not gender specific? So if a stallion gets darted, it would somehow make his reproduction infertile as well. So there would not be so much time into finding out whether the wild horse is a mare or a stallion.
Yeah, so there's been a couple studies that have looked at male fertility control. Unfortunately, there hasn't really been anything that has been um, very efficacious at scale. So right now, there's not really an option to treat the males. Um, excuse me. If a male is treated with PZP, absolutely nothing happens to him. So if by any chance, you know, anything happens and a male is darted, absolutely nothing happens besides he gets a little prick and he might be a little irritated at that. But and good news, especially because of how bands are set up, and horses have relatively large visible external genitalia. It's not too much of an ask. So right now, it's pretty much primarily just mare treatment.
All right, does anybody else have any other questions? That was really great and really great information and really interesting, very interesting study. So thank you for sharing that and thank you for all your work with this. Um, Anybody else have it? You have any closing thoughts or anything else you want to add?
Just going to say, my email's up here. Feel free to email me if you have any other questions. Um, and I'm always open to have a discussion.
All right. Well, thank you and
Thank
thank
you
you
guys for
everybody.
listening.
Yeah, thank you everybody for being here. And the rest of the summit will continue tomorrow morning at 10 a.m. with John Eagle Sr. from the Standing Rock Reservation. So hopefully you guys are signed up for that and the rest of the programs we have this weekend and next weekend. So I look forward to seeing all of you. And thank you again, Nicole, for doing this. We appreciate you and all your work.
Thank you guys. Have a good one.
Thank you.